So why did you choose this career?
Well, I was interested in engineering because it seemed like it was both creative and real, like real physical. You actually manufacture things, you know, so.
What math was needed in preparation for this career?
Well, you got to use addition and subtraction, and multiplication and division, and geometry and trigonometry.
Did you go through any training for this job?
Yes, I took a lot of math classes, and I have a couple of years at the university and a couple of years at the VOTEC.
And did you sign a disclosure when you first got this job?
I did, and I think you'll always, most any place you ever work, you'll have to sign a non-disclosure agreement, which is a way of saying that if you ever leave here, you won't take any intellectual property with you to the next place you go work.
How do you use math in your job now?
We use math in a lot of different ways here, but generally it's to locate features on a part using a machine to remove material.
Okay, and do you use math by hand?
We do some, but generally you have a software like AutoCAD to automatically generate those features for you. And but we do have to know the formulas for, like, when we're writing a programming code, we'll need to know the basic function. We may not have to solve it, but we'll have to know that function so we can use it in a program code. This is a sine bar, and it is used to generate various angles. And you have to calculate what angle you want and find the sine of that angle. The sine of that angle will give you the height of this side of the triangle. And whatever that height is, we find gauge blocks of that thickness to put underneath it. Magnetize it. And then that will give you the angle, and then you can put that in a vise and put a workpiece on top of it and machine it flat on top, and that angle that you want will be produced. Something that looks more like this. I didn't draw it very well. And we're asked to have a let's say this angle needs to be 76 degrees between here and here, right? So how would we calculate? We really want to know the angle between this line and this line. So what would that be, Sarah? Between that line and that line, what is that angle?
14 degrees.
All right, exactly, 14 degrees. So let's set this up.
Good job, Preston.
Because the workpiece is going to sit on here, we need to tilt this up at 14 degrees so we can machine a straight line right across here like that, thereby producing that, right? So if I want to raise this up 14 degrees like that, I need to know what thickness of gauge block to put in here, right? All right, so tell me what that would be. Well, what would this angle be right here? You guys are the students, right? Well, we have, let's make it a little simpler. We have a triangle like this. We have a known angle of 14 degrees. So
which side do we need to find?
we need to find this side right here. To solve that, sine bars are always made to an even numbered length to make it easier for you. And this one here, you measure here, it's like 5 inches long. So we know that for the purposes of calculating what angle or what feeler gauge we're going to put under it, we can use 5 as the bottom of our. So what function? I think that's right.
Tangent of 14.
Tangent of, yeah, tangent of 14 degrees is equal to
Opposite over adjacent.
x over 5, right?
Right.
So solve that for me.
So then x would equal 5 times tan of 14. Right?
Mm-hmm.
So it's x equals 1.25.
Sounds right. So come over here and pick out 1.25 inches. 1.25 is, we'll take an inch, and where's the 0.25? Oh, we don't have one. Take a 0.2, and I mean 50 thousandths, which is there. So you stack all those up on top of one another. You put it right underneath there. Slide it in some more. It's under that. Right. And there you go. So there's your angle, right?
Mm-hmm.
All right. Now what we'll do is we'll set our workpiece on there, like that. And we can set it up in the machine like that, where it holds it together like that, and we can mill the top of it, and then it will produce a part that looks like that. Does that make sense?
Yeah.